Hello everyone. This is the fourth part of lecture 1. So in the last video lecture, I talked about the different types of fermentation technique, right? The batch, feed batch, continuous processes, and I also talk about the difference between batch and continuous process. So in this video lecture, I'm going to talk about the advantages and disadvantages, that is merits and demerits of continuous fermentation process in comparison with the batch fermentation process. And these are important. Actually, we need to understand these merits and demerits because these are important to achieve our goal for the fermentation industry. Okay, so now what is the goal or fundamental objective of industrial fermentation? To get maximum yields in minimum cost. I mean, every industry they want to produce maximum product, but at the same time they want to spend less. With less cost, they want to produce maximum product. So, in a fermentation industry, how we can achieve that? So, this goal can be achieved by developing the most efficient mode of fermentation for each particular process. Okay, so to choose the most efficient fermentation process, we need to understand the types of the characteristics, merits and demerits of the continuous and batch fermentation process. Okay, so now let's talk about the merits and demerits of continuous fermentation process. Okay, okay, first the merits of continuous process in comparison with the batch fermentation. Then I will talk about the demerits. Okay, so now first the merits. So I mean, if we use continuous fermentation process, we can use a smaller bioreactors to produce similar amount of product in comparison with the batch fermentation process. Okay, so like suppose you want to produce, a certain amount of your product. So if you want to do it by using batch fermentation you have to do it at once, right? So that's mean your fermenter size have to be big. Okay, but in continuous fermentation process we can continuously harvest some of our products, so that means we actually don't need a very big fermenter. Okay, so this is one merits. And another one, I mean, in batch fermentation, okay, as we have to use big fermenter, so every machineries that we'll use, that we have to use after the fermentation have to be big, such as the cell harvesting equipment or the equipment to break the cells, all have to be big. Okay, and also, I mean, in as in the batch fermentation, we have to ferment a big amount of substrate, right? So that's mean after the fermentation, in the purification process, we have to deal with huge amount of fermented products. Okay, so it will increase the cost and also. Okay, so uh, however, the continuously grown cells are produced a little bit at a time, so that the equipment required for cell harvesting, cell breakage, and downstream processing can be much smaller in case of continuous fermenter, right? So everything have to be big. You have to deal with lots of media and the harvested products in case of batch fermentation. But in case of continuous fermentation, as we need a smaller bioreactor or fermenter, so every machineries or every processing steps, I mean the all those downstream processing steps, they will be smaller in comparison with the batch fermenter. Okay, this is at a time, I mean, easier to do, and also it will save us some money. Okay, so then in case of continuous fermentation, we can avoid the downtime between batch runs, which is longer in case of batch fermentation process. Because in case of, I mean, when we will do fermentation using batch fermentation process, so how we do that? Batch wise, right? So first you have to do, I mean, run one batch fermentation. So, and after it is done, you have to harvest your products, you have to clean the bioreactor sterile. That means you have to prepare it for the next batch. So it will cost some time, it requires some time. This time is called downtime. Okay, But in case of continuous fermentation, it will continue for certain period of time. So basically there is no downtime there. We can completely avoid the downtime in continuous fermentation. Okay, so we can save some time. So saving time means saving money. Okay, and then in case of continuous fermentation, as we are continuously okay, supplying fresh media into it and also continuously harvesting some products. So by doing this, we can maintain a uniformity in the physiological state of the cell. Okay, so as we can maintain the physiological state of the cell, our yield will be consistent in quality. Okay, because who are producing the product here? The microorganisms or the organisms that we are using in the fermenter. So if and these are biological things. So the quality of the products produced by microorganisms will depend on their physiological state. So if the physiological state is uniform or same, then the product quality will be persistent or consistent. But in comparison, what happened in case of batch fermentations? Okay, it's very difficult to maintain a uniform physiological state there, because in batch fermenter, the environment inside is continuously changing, right? Because the media is getting used up. Okay, and more metabolites is continuously adding up there, so which will change the physiological state of the organisms, and thus ultimately it will hamper the quality of our product. That means we will not get a consistent quality product. Okay, so now we talked about I talked about some merits of the continuous process fermenter, but it also have some demerits, okay, in comparison with the batch fermenter. So number one, uh, usually the batch fermentation we run it for like several hundred hours, something like between 500 to 1000 hours. Okay, so as it's run for long, so sometimes it can create some problems, such as suppose you are using a microorganisms which carry recombinant plasmid. So whenever a microorganisms, okay, it grows, you are running your fermentation process for like 500 to 1000 hours. That means your microorganisms will divide many times in, okay, in this period. So there is a chance that during this time your organisms will release the recombinant plasmid. Okay, so if it release the recombinant plasmid, that is free from plasmids, it's actually easier for that microorganisms to grow, to multiply. Okay, and the microorganisms without the recombinant plasmid, it requires less energy to multiply. Okay, so that means if it lose the plasmid, then it will multiply faster. Okay, and it will overwhelm the overwhelm the recombinant microorganisms, and these microorganisms, that is which is free of that plasmid, it will grow, but it will not produce any product. That means you will get less product here. Okay, so however, this problem can be solved. Like suppose if you use if you integrate the gene into the genome of your microorganisms, in that case there is less chance that your that microorganism will lose this gene. Okay, so we can avoid this kind of problem by integrating the clone gene into the genome of the microorganisms. Okay, however, there is another chance. If the continuous if by any means the continuous fermentation process get contamination, okay, from some foreign, like with some other microorganisms, it also can cause a similar type of problems. Like say suppose the contaminate microorganisms, it can grow more faster than your microorganisms, your producer microorganisms. Then what will happen? So eventually that contaminant microorganisms, it will overwhelm your microorganisms. Okay, so that means eventually you will get very less product. Okay, so another thing, continuous fermentation, they are more prone to get contamination in comparison with the batch fermenter, because batch fermentation, it happens in a closed system. Okay, we put everything there, the raw materials, the organisms, we close it, and just we turn on the fermentation. Okay, so it keep going on until we stop it. Okay, we don't add anything, we don't harvest anything from there, so there is less chance of contamination here. But in case of continuous fermentation, we continuously add something there, right? We continuously add fresh media or other raw materials or substrate there, and we are also at the same time we continuously harvest some product from there. Okay, so as it's a continuous process, there is a chance that it can get contamination during this process. So to avoid this one, we have to strictly maintain the good laboratory practice here. I mean everything we need to supply into the fermenter need to be sterilized. Okay, all the equipments that are associated with that fermenter have to be sterilized. Okay, so this will greatly increase the cost. Okay, and finally, another demerits of the continuous fermentation process. Okay, actually this one actually not a demerits of solely the continuous fermentation process. This is the demerits of all the types of fermentation process. It's and this demerits is related with the culture media. So now, I mean, during our development stages, basically where we do the research in our lab, and in our lab, the reagents, the media we use are, the quality of those reagents and media are strictly maintained. Okay, but in case of industry, in case of the main fermenter, okay, there is a high chance that you cannot strictly maintain the characteristics of quality of your raw materials. Okay, it's normal, right? Because the characteristics of the raw material, the substrate or the media that you will use in your fermenter depends on the quality of the raw material. So if the quality of the raw materials vary, eventually the quality of the media that you use in the main fermenter will also vary. So it means, you can get a product with different quality than the product that you get in the laboratory, and also there is a chance that you will get less product in your final fermenter in comparison with the amount of product that you get during your laboratory experiments. Okay, so these points are important. I mean, the differences among the fermentation processes and merits and demerits. You need to consider all of these things when you have to choose the most suitable or appropriate fermentation processing for your industry. Okay. Okay, so we are done with the types of the fermenter. In the next lecture, we'll talk about the design of a fermenter. Okay, so till then, be safe. See you. Thank you.